Okay, so let's continue and do some extra examples for 7.4. So let's say we have the following. And the first one we're going to do is uh, 4x plus 5 times 2x plus 3. Okay, so these are two binomials, and so we're going to use the FOIL method. So we're going to take first times first, and first times, or outer, first one and outer one. Then we'll take the inner ones, and then we'll take the last ones. So 4x times 2x is going to give us 8x squared. 4x times 3 is 12x. 5 times 2x is going to be plus 10x. 5 times 3 is 15. Those are like terms, so we get 8x squared plus 22x plus 15. So this is a nice one where you can just FOIL, boom, 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 and we have our four terms that come out. The two middle terms are like terms, so we can add those together. All right, so let's do it again. And this time, instead of writing them, in one whole line, we'll kind of do like we started to do last time and make two rows. So let's say we have x plus 3y times 3x plus 4y. Okay, so again, it's just using FOIL, first times outer times inner and times last. So x times 3x is going to give us 3x squared. And then we'll have plus x times 4y, so it's going to be 4xy. Then we have this times this, so it's going to be 9xy. So let's, like I said, write it down below so we have everything in a column we can add together. And then 3y times 4y, and that's going to be plus 12y squared. So now we can add down, so that's going to give us 3x squared plus, then we have 13xy plus 12y squared. Okay, so just taking the 9 and 4, get 13, still keep our xy, and then our 12y squared. Okay, so again, you can do it where you write it all straight across, or you can do, two rows and then add the columns down together. Now, the second way is going to be more useful when you have, a trinomial times a trinomial, or even a binomial times a trinomial. So it all depends on what you like and how you want to do it. But I think I'll do the next two in the, adding columns format. All right, so let's say we have 6x plus 3y times, let's say we have 6x squared minus 7xy plus 4y squared. So again, we're going to distribute each term of the first polynomial times each term of the second polynomial. And so when we do that, we'll have a 6x times 6x squared. So that's going to give us 36x to the third. 6x times a minus 7xy, so it's going to be a minus 42x squared y. And then 6x times 4y squared, so that's going to be plus 24xy squared. So you remember we were supposed to write these in standard form. And so what happens usually is one term will be decreasing in power, hence the x's are going from 3 to 2 to 1. And the other term is going to end up increasing in power. So in this case, the y. So the y has none here, has 1 here, has 2 here. So while one goes up, the other one goes down, and vice versa. And so usually you pick the first one, which is in the alphabet, in this case x, and make it the first one as your first number in standard form, the highest degree, and then work your way down from it. And then the other one, the y in this case, is going to increase as you go to the right. All right, so now we take 3 times that. So 3 times 6 is 18x squared y. So that's going to be plus 18x squared y. And then we have 3y times 7xy. So that's going to be minus 21xy squared. And then we have 3y times a 4y squared. So that's going to be plus 12y to the third. And so now what we can do is we can add these together. And so when we do that, we have, where my pen to go here? 36x to the third. Now here, if we need to, we can borrow, that's that. And so 8 goes in there, that's a minus, and that's a 4, that's a 2, and that's an x squared y. All right, and so then what we have? Then we have 24 minus 21 is going to be plus 3xy squared, and then plus 12y to the third. Okay. So that should be what we get there as far as our final answer. And again, you could have wrote these all out in a single line, and then you would have had to say, okay, well, that one and that one are like, and that one and that one are like, and underline them to make sure you keep those track in place and go from there. But I think lining them up like this really does help a lot. All right, so the next thing I'm going to do is going to be a trinomial times a trinomial. So what I'm going to do is I'm going to go ahead and make a new page and then write that out. So it's going to be even longer going down. All right, so if I have this one, it's going to be 4. So let's say we have 7u squared plus 8uv minus 6v squared times, let's say we have 6u squared plus 4uv and then plus 3v squared. All right. So again, each term here is going to be multiplied by each term over here, and then each term is going to be done again. And then if we change the color so we can see that third one, then it's going to be here, here, and there. All right. So again, I'm going to line these up on top and bottom. And so I'm not going to put it over here. I'm just going to put it right below where we have here. So 7 times 6 is going to be 42. Then we'll have u, and 2 is going to be 4. Okay. Then 7 times 4 is going to be 28. Then I have u squared times u, so it's going to be u cubed v. Now 7 times 3 is 21, so plus 21, u squared v squared. Okay. I'm going to take 8uv times that, so 8 times 6 is 48 u cubed, so plus 48 u cubed v. And then we have 8uv times that, so it's going to be 32 u squared v squared. And then I have 8 times 3, so it's going to be plus 24, and I have u v cubed. And so now I'm moving on to the 6 here. So I'm minus 6v squared times this. So it's going to be minus 36u squared v squared. So it's going to be minus 36u squared v squared. And then we have here minus 24uv cubed. And then minus 18v to the fourth. All right. So again, that would have gone clear across the screen, and I don't think I would even fit it in that little space here. So that's why I did it below. All right, so now we just have to kind of add and subtract here. So we go down here, that's going to be 42u to the fourth plus, now we have 8 and 8, 16, carry the 1, that's 676 u cubed v. And now, let's see, it looks like it's going to be a positive. So we're going to have 53, 21 plus 32 is going to be 53 minus 36, borrow. So it's going to be a 17. So it's going to be plus 17 u squared v squared. Well, those nicely cancel, so we don't have anything there. Then minus 18v to the fourth. Okay. All right. So that looks to be what my final answer is, as long as I've done all of the math along the way correct here. So let's see, 7 and 6, 42, then 28, then 21, and then that's 48, and then 32, and then 24, and that's 36, and then that's 24 and 18. So it looks like that should be correct there. All right, so let's do another one. The next one I'm going to do is one where we had the number out front. So let's say we have a 3x squared out front, and then we have a 2x plus 3 times a 6x plus 9. All right, so first I'm going to FOIL the binomials. So I'm going to go ahead and do that multiplication first, and then I'll do the 3x squared times that once I get the two binomials multiplied together. So here I have a 2x times a 6x, so that's going to give me a 12x squared. 2x times 9 is going to be plus 18x. Then 3 times 6 is going to be plus 18x. And 3 times 9 is going to be plus 27. So again, I have like terms, so I have 3x squared, then 12x plus 36x plus 27. Now I distribute my 3x squared, and my squared disappeared there. And so now I have 3 times 12 is going to be 36x to the fourth. Then I'll have plus, now if I take 3 times that, that's going to be 18 and 678 x to the third. And if I take 3 times that, that's 21, that's going to be 81. And then that will be my final answer. Oh, there's x squared on that still, sorry. So we have x squared. All right. So that should then be my answer. Wait, that doesn't look right. Oh, that's 10, 108. Saying that doesn't look right. All right, so let's erase 78 and put a 108. All right, so 108. So yeah, it's 9 plus 1, 10. Okay, 108. So that looks better. Okay, so that would be when I do the FOIL first, followed by multiplying by my monomial at the end. Then let's do one last example, and this one's going to be with the two functions multiplied together, basically. And so let's say we have let f of n equal negative 2n squared minus 5n, and let's let k of n equal n plus 5, and we want to find f dot k of n, which is basically f of n times k of n. Okay, so when we do that, we're going to have a minus 2n squared minus 5n times n plus 5. And we've got two binomials, so we just FOIL it first, outer, inner, last. So minus 2 times 1 is going to be minus 2n to the third. Minus 2 times 5 is going to be minus 10n squared. Minus 5n squared. And then a minus 25n. So we have like terms here. So that gives us a minus 2n to the third minus 15n squared minus 25n. And then that should be our f dot k of n. Okay, so that takes us to the end of the examples for 7.4.